Hello my friends and welcome to the practical activities of part 2 on Deep Convolutional Q-Learning. I can't wait to start because now we're gonna have a more challenging task of building an AI, because now instead of having just a simple vector of input state, with just one dimension, we will have images. Because indeed, with the convolutional part of the Deep Convolutional Q-Learning model, we will have convolutional layers that will act as eyes for our AI. In other words, our AI will be playing the game of Pac-Man, because this is going to be our environment for Module 2. It will be playing the game of Pac-Man with its own eyes, which are exactly the convolutional layers. So this is super exciting. I can't wait to start to implement this, and therefore welcome to Gymnasium again. I'm going to introduce to you right now the environment we'll be working on for this part 2. So it's going to be in the Atari environments, of course. Then you're going to expand this to see more environments, because of course the environment we're going to play on for this module 2 is Pac-Man. So you just have to scroll down a little bit and you will find it in the P's. Here we go, Pac-Man. Let's go inside. Alright, so let's have a look at the different important information here. First, I'm sure that you all know Pac-Man, that you played it at least once in your life. I remember playing it a lot of times when I was a kid and I absolutely loved it. So I'm very excited to now build an AI to play it. And before we look at the action space, the observation space, I want to show you something important at the bottom of this page, which are the variants. Because now that we have a much more challenging task to do, since the input state is much more complex, we have to be reasonable and choose an environment that is not too complex for our AI. Because indeed, if we go, for example, with the Ali Pac-Man v5, we will need big resources to train our agent. And besides, you know that not every model can solve every environment. And actually, the Deep Convolutional Q-Learning model is not powerful enough to solve this particular variant of the Pac-Man environment, Ali Pac-Man v5, which is the most complex one. However, two things to say about this. First, the A3C can solve this. That's the more advanced model we will build in part 3, even though we will build it for Kung Fu. And then the second important thing is that our Deep Convolutional Q-Learning model we will build in this part 2 can solve some variants of this Pac-Man environment. And the one that is not too complex and therefore doesn't require too much computing resource for the training will be this one, Miss Pac-Man Deterministic V0. Now, the deterministic part in the name can be a bit misleading. Of course, it's not going to be a fully deterministic game. What they mean here by deterministic is that part of the other agent's actions will be deterministic, as opposed to, intelligently stochastic. But that's only a part of it. Of course, most of the other agent's actions, the monsters, will have intelligently stochastic actions, but part of it will be deterministic, so that it makes the environment less complex and therefore easier for us to train our Deep Convolutional Q-Learning model, which is important because I want everyone in this course to be able to train our agent and not require too much compute-intensive resource, without which you wouldn't be able to get a good score at the end. Alright, so we'll choose this environment. It will be perfect to illustrate what the Deep Convolutional Q-Learning model can do, and besides, it fits the resource we have in our Google Colab notebook. Okay, so now here we go. Let's do this. Let's take again that link I sent you just before this tutorial. So we're gonna open it in a new tab. Remember that I am in my new Gmail account just so that I can do everything with you from scratch. And so now it's just like I'm a student doing the steps with you. And the steps we have to do now is to go, of course, into the part 2 Deep Convolutional Q-Learning folder. And then same, you will have the complete code with the full code and the full results, but don't look at it until we implement the whole code together and discover together the results in the end. Now, of course, what we're going to open is the partial code notebook. And then remember that this is a read-only notebook for the simple reason that everyone has access to it, and therefore no one should do any modification on this. Therefore, in order to be able to do some modifications and code on it, just like what we did in module 1, we're going to create a copy of this notebook by clicking File here and then Save a Copy in Drive. There we go, it is creating a copy, which we will find in our drive in the Colab Notebooks folder. If we refresh this, oh no, here it is. That's the copy that was just created, and now you own it. As you can see, the owner is now me in this particular artificial intelligence A to Z gmail.com account, as opposed to here where I was the owner from my other account. Okay, so now you are the owner. You can, if you want, rename this very simply Deep Convolutional Q-Learning for Pac-Man partial code. And now here we go. Let's open it and let's start coding. Let's start building our new AI, the Deep Convolutional Q-Learning model for Pac-Man. I can't wait to start with you in the next tutorial, and until then, enjoy AI.